Alright, at this point we're ready to start building our ladder diagram. Let's go ahead and click on the first rung and make sure you have a dotted box around the line here. This is where you're actually going to be inserting uh, to the line. Click on the contact button, and at this point you're going to see a normally open contact with 3 red question marks on top of it. Anytime you see 3 red question marks, that's CoDeSys prompting you for a variable name. So select the 3 red question marks and click on Edit, Input Assistant. Notice there's a shortcut F2 on your keyboard that you can press to get to this screen. And under Global Variables, you'll see the 2 inputs and 2 outputs variables that we had declared earlier. We want to select input 1 and press Enter. Select the line again, insert another contact. Again, select the 3 question marks, Edit, Input Assistant. I'm going to tie that to input 2. Press Return. Remember, this was a normally closed contact in our example. So if you right click on the contact and you can select Negate, you'll see that it's now a normally closed contact. Again, select the line off to the right and you want to insert a coil. Input Assistant, we want to tie this coil to output 1. Press Enter. Alright, we've created our first rung. Ready to insert our second rung. If you position your mouse on the first rung in the gray area here, and you right click, you have a drop down menu where you can add networks. Our second network is a TON function block. So if you insert a box with enable, it'll insert an AND, which is always the default block that's added. We want to change the name to a TON. As soon as you change it to a TON, CoDeSys identifies that this function block has various inputs and outputs, and you can see with the red question marks that it's prompting you for some more information there. We're going to give this timer a name. If you select the 3 question marks at the top and type in T1, press Enter, you will see that window pops up for the variable declaration window. And you want to make this a VAR class. Again, the name is T1 and the type is TON. And go ahead and click OK. You'll see that it added it here at the top, indicating that this variable is now part of the program. For the input on this function, we want to tie this to input 1. So you can either highlight this and type in input 1, or you can use the input assistant again and press Enter. For our preset time, we want to make this a constant of 2 seconds, and the notation for that is T pound 2S. For our Q, we want to tie this to a variable called T1 underscore done. So if you select the 3 question marks and type in T1 underscore done and press Enter, it will prompt you to declare this variable. We're going to make sure that it's type Boolean. Go ahead and click OK. And again, you'll see that he added it at the top of the screen here. And for our ET, which is our elapsed time, we want this variable to be called T1 underscore elapsed time. Press Enter. We want to change this. It's actually not of type Boolean, it's of type time. Go ahead and click OK. Alright, that's our second rung. Right click and add another network after this one to create our third rung. Again, make sure you have the box highlighted on the line. Insert box with enable. You want to change this from an AND to a CTU. Again, CoDeSys identifies that function block. And when you call this C1, press enter, and make sure that it is of type CTU. Click OK. Our CU variable, go ahead and select the 3 question marks for CU, and I'm going to use our input assistant. Go to local variables. This displays the variables that are defined for this program. We want this to be tied to T1 underscore done. Press enter. Reset we're actually not going to use, so you can just hit the delete key to clear out those question marks. You can't leave those question marks there. If you try to compile with the 3 question marks, it will give you an error at runtime. Select the 3 question marks next to PV. Type in the number 3 for our constant. For our Q, we want this to be called C1 underscore done, and that is a Boolean. Okay. And our CV, we want to be C1 underscore count value. And that is a word. You can either type in word here, or you can click this button off to the right, which gives you a pick list. If you're not familiar with the different variable types, this is a helpful tool to identify which variable type you need. Click OK. Now we're ready for our last rung. Right click on the gray area again, insert a network after. The 4th rung has contact. Click global variables, input 1. Select the line again, another contact. Again, F2 is a good key shortcut for the input assistant. Press enter. Input 2 we want to negate. Select the line, insert another contact. So we want to be output 2. And at this point we want to add a parallel contact. So if you make sure you select output 2 and select the parallel contact, you'll notice that it added a parallel contact to these 2 inputs. And this we want to be tied to C1 underscore done. That's a local variable. Press enter. Alright. You can see we've added our 4 rungs. We're ready to compile this to see if we have any errors. We click on Project and Rebuild All. You should see 0 errors, 0 warnings at the bottom of your message screen. If you have a number here, it indicates how many errors you have, and you can scroll up in your message window and it'll tell you which line you have the error in. For this example, I will introduce an error to show you what that would look like. I'm just going to change this from input 2 to input 3. Notice it's asking me what I want this variable to be. In this case, I actually want to hit cancel. So input 3 we know doesn't exist anywhere in our program, so when we compile, again you can hit F11. Notice here I have one error, error 4001. In our PLC PRG program, which is our main program, on line 4, input 3 is not defined. So here it's explaining to me what the problem is. I'm going to go ahead and change that back to input 2 and F11 again. And there we go. Also, it's worth noting that this tells you how much memory is in use for this program. We're using 2,974 bytes.